Hello, this is Tony Nichols, co-founder and Chief Technical Officer of Great Ideas. And in this video, in the course Enterprise Architecture with examples using Microsoft.NET Blazor, Azure, and Great Ideas Trellis Spark, we're going to be looking at the topic of application architecture. So the purpose of this video is to give you an overview on what do we mean by application architecture. And although my primary focus will be on service-oriented architecture, we're going to focus on a few different things. We're going to look at how do we write better code, how do we write less code, why we're focusing on service-oriented architecture. We will then look at what is service-oriented architecture, and then we will cover a pragmatic framework for service-oriented architecture called Data Agnostic Services. As ever, we will then be following up this introductory video with a series of deep dive videos on each of these topics. So the first question we need to address is how do we write better code in the first place? So irrespective of whether we're building a SOA-based application or whether we're building a monolithic application or a client server application, how do we improve the quality of the code that we're writing? Well, over the last 5-10 years, security and privacy have become a primary focus for many enterprise applications. If you were looking back 20, 30 years ago, security and privacy were things that were sort of layered on as an afterthought. And essentially, most times a user who has access to the application could pretty much do anything. Over time, we've become more focused on understanding user roles, understanding user access rights, and so on. And the focus really has moved from an application perspective into making sure that everything we write is secure and private by design. GDPR, which is the European standards that were introduced a few years ago, really lay this out. There are a bunch of things in the GDPR standards that talk to the business directly about privacy and controls and ownership of data and who can see data and so on. And a lot of those are business driven. But when you're looking at the application implications of something like GDPR, most of it comes down to making sure that the code we're writing, the data we're storing, and how we're hosting it has been designed to be secure and private. Another thing that we need to address to make sure that we're writing better code is to use a standards-based framework. So what we mean by that is that your organization has figured out how you want to write code. And you've got your own framework, which may be based on somebody else's architecture, may be based on whatever, but you have a framework. And within the context of that framework, you have defined a set of standards for things like security and privacy, right the way down to coding standards, naming conventions, and so on. So by having a set of standards and then ensuring that those standards are applied equally to all of the code that you have written, you can bring up the standard, the overall standard of the code, to a common benchmark. And this gets away from some developers providing high quality code, some developers writing low quality code. Essentially, what you're aiming for is that when you review any piece of code, because it complies to your standards, you shouldn't be able to tell that this code was written by Rob or this code was written by Tony. Ideally, you should be looking at that code and you wouldn't know who had written it because they're using the standard layouts, the standard commenting conventions, the standard naming conventions, and so on. So essentially, it takes away some of the personal craft of writing code, but it does mean that you're enforcing the use of best practices through all of the code that's being written. And you should also make sure that the code is reviewed by an independent author to make sure that the standards have actually been applied correctly. Flowing from the use of a standards-based framework is the idea of separation of concerns. So ideally, when we're writing a piece of code, it should be storing data, it should be moving data, it should be displaying data. There are so many cases where I've been reviewing applications that have generated problems, where I might be looking at, let's say, a form that's being displayed to a user, and it's not just displaying the form to the user, it's doing a whole bunch of different storage operations. There might be some workflow buttons on there that are essentially executing a whole bunch of workflow actions, for example, processing invoices or orders, and I've got the actual workflow code embedded inside a button inside a form that's accessing databases. So as you get into looking at standards-based frameworks, one of the things that you want to try and build into that framework is this idea of a separation of concerns, so that all of the code associated with in workflow is in a set of business objects that can be independently deployed and tested, irrespective of the form or the user experience that's actually generating them. Another thing to bear in mind when we're talking about writing better code is it's always easier to build small and simple components. So ideally, you don't want to be writing tens of thousands of lines of code in a function with 15 levels of indented control flow statements. Essentially, when you start getting to that level of code, it's very difficult for a human to actually read, understand, comprehend that level of size and complexity. So when you're looking at code like that, look for opportunities to refactor it into smaller functions with fewer logical control flow statements. Ideally, you don't want to be indenting more than 3 or 4 layers at the top, and even better if you can keep it down to 1 or 2 layers of indentation. So small and simple components, they're easier to build, they're easier to understand, they are easier to test and maintain over time. Even given the fact that we want these small and simple components, one of the key things that should be imposed by your standards-based framework is the idea of defensive programming. So whenever you're writing a piece of code, you should always be looking to anticipate failure. So for example, if you're taking input from a user and it's supposed to be an integer, validate that it is an integer. And if it's not an integer, make sure you're providing appropriate feedback to the user immediately. If you're dividing one number by another number, make sure that the number you're dividing by isn't 0. Okay, so you could just let it throw an exception and handle the exception, but better to actually check for the failure condition and make sure that you've got some elegant way of reporting or handling the failure. If you're opening a file, if you're writing to a message queue, always anticipate those types of errors that you may encounter and make sure that they are built into that small and simple component. So even though you're only restricting yourself to these 2 or 3 layers of indentation, make sure 1 or 2 of those layers is actually associated with defensive programming, actually checking that the logic of your function is doing what it's supposed to be doing. And then when something's out of bound, make sure that you're logging the fact that something was wrong, the number was out of range, that the file couldn't be opened. Make sure that you've got appropriate logging at the point where the failure is being detected, and then where possible, mitigate that failure. So in some cases, you'll have like an atomic transaction inside a T-SQL where you've got a commit for a transaction. In some cases, you won't be able to do that. In some cases, you're going to have to execute some sort of compensating transaction. So defensive programming, absolutely key part of your standards-based framework, something that everybody should be doing as we're building out our code fragments and our functions. Another thing that we can do to improve our overall code is to use automated testing. So where possible, and because we have refactored and we've used separation of concerns and we don't have workflow embedded in user experience forms, we've got workflow in service classes that only execute a particular function. Those are great focuses for applying automated testing tools for. And during automated testing, we should be testing both the happy path. So what happens when you actually put in an integer and the integer isn't 0 and we're using that to divide this other number? So look for the happy path tests. Does it work as it was designed? But even more importantly is also figure out the sad path tests. So what happens when I put in 0? What happens if I put in a negative number? As well as making sure that your automated tests prove that the happy path and the functionality works as designed, also add additional tests to test your defensive programming checks. Does your defensive programming check correctly detect and log and recover from a 0 input or a negative input? And then wrapping everything up, look at your DevOps standards and processes. So it's not just about writing the code in the first place. Okay, when we're looking about a piece of code, it exists for a reason. It exists because there are requirements that are driving the design and implementation of the code. Once that code has been done, we're going to drop it into a production environment where we're going to operate it potentially for decades. We need to make sure that when we're writing code that we've paid attention to the entire process of development operations, from the specification of the requirements through to the design, implementation, testing, deployment of that code, and then the operation of that code over an extended period. The next question we need to ask is, how do we write less code? Okay, so for a software developer, the idea of less code, we don't want to write code. I was watching an architecture video a few years ago, and a quote that struck me that I'm paraphrasing here is that functionality is an asset, code is a liability. So the business needs as much functionality as we can give it, as much of the correct automation and processing as possible. That is an asset. That is helping the business to operate. Functionality is an asset to the business. But every line of code that we have to create to provide that functionality is a liability. We have to specify its requirements. We have to design it. We have to implement it. We have to test it. We have to change it. We have to regression test it again. We have to put it into operation, and we're maintaining it for years. So code is a liability. What we really want to be doing as developers is looking for ways to write less code. So there's a few mechanisms out there in the general market at the moment that we can look at to write less code. One is essentially the idea of code generation. So this is basically taking some sort of model of what the application is going to do, and then instead of some human writing the code, then we use a code generator to generate the first version of that code. So we're going to do some tutorials on code generation approaches, but also the limitations of code generation. So using a model to produce version 1 of the code makes a ton of sense, right? But then you get to, okay, well, now I need to slightly customize this code that was generated. So I create version 1.1, 1.2, 1.3 from the version 1 code generation. And then maybe 6 months later, it gets to the point where I'm up to, say, version 1.23. Okay, and now I'm going to make some changes to the underlying model, and I'm going to generate version 2 of the code. Now, what happened to version 1.23? How does that get incorporated into version 2? So that can be a challenge, where we actually have to customize code that we've actually just gone through generation, because then the use of the model and the code generator becomes a problem in and of itself. The other issue with code generation approaches that we're going to talk about is the limitations with respect to how much customization can you build into the code generation. So the more custom type features you want in the code generator, the more complex the model, the more complex the code generator, more likely it is that the code generation itself is going to fail. So those are issues that we also need to consider. There's a lot of buzz in the marketplace around no-code, low-code approaches. And essentially, a lot of these low-code, no-code approaches are using code generation approaches in the background to hide the code that would normally be created. And you have the ability to add some custom features into the code generation. So essentially, it's a mismatch of code generation and custom. And again, there are going to be limitations with how far you can get with these low-code, no-code approaches. And we'll be doing a couple of tutorials on that as well. One of the key things about writing less code is this next point. Build open-ended services that empower users to make human-level decisions. So essentially what we're talking about here is that when we're writing a piece of code, we want to empower a user to do an action. So that action might be to format and send an email, to process an order. So essentially what we're trying to do is make that service as open-ended as possible so it can be used in as many different circumstances as possible. And it's essentially empowering the user to automate something that they're doing on a day-to-day basis. But bear in mind that user is a person, is a human being. So at the same time, we want to remove all of the drudgery steps that they do the same way every time and all of that manual effort. We also have to acknowledge that at some point, that person is there because there is a human level decision that needs to be made. So we might be, say, talking about a customer. Customer wants to place an order. The order is going to take the customer over their agreed credit limit. And 9 times out of 10, the answer is no. Okay, that you can't place this order because you're over your assigned credit limit. But this might be a high priority customer. This might be a customer who's spending millions of dollars a day. There may be a whole bunch of reasons that a human being would just look at that and go, you know what, it's going to take them over the limit, but absolutely we're going to do this. So, if you basically try and over automate the system to make these decisions, then one, you've increased the complexity of the solution that you're building. And you've also boxed it in that you now have basically something in the system that's going to not allow that order to be processed. And that's going to make the system less flexible, less easy to maintain and modify over time, and may also generate, decreased levels of customer satisfaction. But if a human was actually able to make a decision and override the process, then you would have got a better result. So the thing to remember when you're looking at the code that you're creating is make sure that the code you create is empowering users and giving them the ability to make the decisions that they're able to make and automating all of the mundane tasks that don't really require a human level decision. The other thing to do when we're writing less code is to build and reuse generic services. So essentially what we're talking about here is providing, let's say, one service that sends emails. Right? So instead of having like 10 different applications with 10 different services that all basically send emails, let's just have one service that sends emails and then be able to reuse that service across multiple applications and solutions. And one thing that we need to have a look at when we're building these generic services is, again, how do we eliminate code and replace it with configuration data instead? So is there a way of having a service, and as we deploy the service, provide configuration values that determine how that service works? So which email addresses I send emails from, which marketing topics is this service going to support, and so on. So when we're looking at writing less code, what we really want to focus on is reusing services, and the best way to do that is to make the service itself generic and dependent on configuration data, rather than hard coding all of the different types of email service we might need. The other thing we really need to do as an industry is stop building applications. The reality check is that most of us are in businesses and organizations with lots and lots of monolithic applications and very few real services. So what we need to do is stop building and replacing applications and instead create services. This gets us away from essentially a rigid box where an application, let's say a customer relationship management application, encapsulates some functionality, encapsulates a set of business rules, and that's it. The user's trapped within the box. They have to use the functionality and services provided within the application in the way that the application wants them to use it. And it's very difficult. We've boxed the users and the business into a functionality in an application, and it's very hard then to evolve and adapt that functionality for use in different contexts. So one of the things that we want to have a look at with a service framework approach is that we want to provide fewer generic services to provide flexibility to the business to adapt and evolve over time as the business needs change. So I've mentioned service-oriented architecture a few times already in this presentation, and it's really time to ask, why should we be focused on service-oriented architecture or SOA? The ugly truth for most of us is that we're still dealing with large numbers of monolithic and client-server applications. I frequently have been engaged by organizations that have had tens, sometimes in the low 100 different applications, all of which have their own data silos, all of which have issues with integrating data between two or more applications. There have been application issues where to complete a single business task, a user's had to log into 5+ different applications and re-enter the same data multiple times. So I've had issues in organizations where the organization has grown through merger and acquisition of several companies, and then they have 7 or 8 different customer management systems. And even trying to get a list of the customers for that company becomes a huge issue, because we may have the same customer in 2 or 3 different applications, and the IDs in each of those applications may be very different. In one application, maybe the customer is identified by name. In another application, they may be given an integer ID. In a third application, it may be a GUID. So it's hard to actually map the customer across the multiple applications and actually get a transparent view of something as simple as how many customers do we have, or how many orders are we processing. So we're still dealing with this. And the issue with dealing with this is these applications cost millions to build. They cost years to build. We've put them into operation, and we've built these integration hairballs where we've got multiple applications exchanging data. And the data exchange is version sensitive. So if I've gone from version 7 to version 10 of this application, I potentially am going to break all of the integrations that I had to version 7. So not only do I have to upgrade the application from version 7 to version 10, I have to look at all of the applications that share information with the application I want to upgrade and make sure that all of those integrations are updated. So it becomes a huge problem. And this has basically led to a whole bunch of integration approaches. And each of these integration approaches has a whole bunch of limitations. So we're going to do a whole bunch of tutorials around, different integration approaches and patterns that have been implemented. So we'll be looking at point-to-point real-time API integrations. We're going to be looking at extract, transform, load, so ETL, batch-based transfer of information through some form of file, whether it's a CSV, XML, etc. We'll look at messaging and buffering solutions. A specific example of that being the Enterprise Service Bus, or ESB, right the way through to looking at integration technologies based around using some sort of entity synchronization layer. So we'll do a whole bunch of tutorials around these integration approaches that are basically necessitated because we're dealing still with these monolithic client-server applications. And again, we just need to reinforce the point here, okay, is that as an IT team, we need to be building more flexible solutions. And really that comes down to, let's get rid of these big applications and start replacing them with services. And bear in mind that when we do that, we're talking about something that's going to take us potentially a decade. This is not something that we do overnight or in a year. This is a long-term architectural thing that we need to do to protect the investments that have already been made and to get the business to a point where they have more flexible solutions to protect the business going forward. So we've talked a little bit about service-oriented architecture, or SOA. Let's have a think about what that means. So if you go back to the original definitions that came out around 2000, the principles of service-oriented architecture are interface first. So contracts define how a service talks to another service. So I would have a customer service, it would have a contract. These are the things that I can do with the customer. Here's the data it's going to accept. We need to understand the granularity of the service. So is it a coarse or a fine-grained service? Is it providing something like, say, create customer? Or is it providing lower levels of granularity in the operations that are available on a customer? So granularity is a topic and a subject of itself when we're looking at this course. So we'll do a whole video tutorial, where we're looking at interfaces in terms of contracts and granularity. But one of the key elements of service-oriented architecture is the idea of abstraction, is that everything that we need to talk about when we talk about a customer is held within the context of the customer service. So essentially, an interface should be complete. When we're looking at the implementation of our customer service, we want to make sure that the service encapsulates everything to do with the customer and that it executes in an autonomous function. It doesn't really need anything else. I can deploy my customer service onto my equipment and it's just going to run. Okay, it may reuse other services, as we'll talk about in operation in a minute, but my customer service is an encapsulated view of what a customer is, how a customer works, what customer data is stored, ideally the user experience. It executes in an autonomous function, so I don't need anything else deployed with it, and it's stateless. So every call to my customer service basically runs as a discrete stateless operation. So ideally, from an implementation perspective, I want to get encapsulation, autonomy, and stateless execution. From an operation perspective, we need to consider a couple of different ideas. So for example, composition. So I may have a service that deals with, say, a customer, but my customer is going to place orders. So I might want a customer service and I might want to produce an order service. Okay, and I might also want to produce an invoice service. And essentially my customer is going to use my order and my invoice service to actually provide some sort of mechanism for customers to place orders and then for me to bill my customer, give them an invoice so I can actually get some money off them. Now, each of those three services follow the implementation rules, encapsulation, autonomy, and stateless. But we also have this extra layer now of orchestration where we're dealing with the composition. Customer needs to talk to orders and invoices. Now, ideally, those services are able to be reused. So my order service that I might build to deal with customers that are, let's say, corporates, maybe I've got another type of customer who is a non-profit. And ideally, it would be nice if I could reuse my order invoice in my non-profit customer as well as my corporate customer. So when we're building these services, we want to consider this generic aspect we talked about in previous slides around building generic services that can be reused. And finally, the other thing around operation is we need to discover the fact that services are even available. So when I deploy my customer service and it goes looking for the order service and the invoice service, it can actually find and dynamically link to those additional services. So this is a huge topic around the principles of service-oriented architecture. And we're going to be doing a lot of training videos to explain how SOA works as a logical architectural framework. So it's nice to have an architecture and a framework. What we're going to be looking at next is web service and API implementations. So going right the way back to the early 2000s, a lot of service-oriented architectures were implemented using web services with SOAP, REST APIs, etc. And some real-time services were being deployed as like Windows services where we were communicating through message queues and channels and so on. So we'll spend a couple of videos talking about web service and API implementations. From about 2005, 2010, we also started looking at microservice implementation. So this is the idea of being able to deploy a container and the container basically containing the service and everything needed to run the service, and then we deploy those within a framework like, say, Kubernetes. Okay, so we're going to do some tutorials around microservice implementations and containerization of services. So if this is all good and service-oriented architecture is so great and everybody should have been doing this now for nearly 20 years, what are the limitations? Why aren't we all there yet? I mean, this thing has been going now for nearly 2 decades, but we aren't there yet. Most organizations are still literally monolithic applications, in some cases, in a lot of cases now client-server applications, but very few organizations are completely service-based. So what are the limitations with service-oriented architecture? And what are the architectural patterns used to address those limitations? So we'll do a couple of tutorials where we're discussing some of the limitations around service-oriented architecture and some of the patterns that have emerged to try and address those limitations in different frameworks. So it should be apparent from the tutorials that we've talked through so far, we've been doing this for nearly 4 decades, and certainly service-oriented architecture and implementations of SOA frameworks is something we've been doing in detail for the last 2 decades. We've put a whole bunch of best practice together inside Great Ideas and changed a couple of the fundamental architectural assumptions that are normally implemented within SOA frameworks. And we've built this alternative implementation of SOA. So it's still SOA, okay, it's still a SOA framework, but we're calling it Data Agnostic Services, and we'll go through the reasons and rationale and why. But it's encapsulating 2 decades of best practices for building SOA. And we have actually implemented that SOA framework, the Data Agnostic Services framework, in the product that we provide called Trellis Spark. And that product is available for you to download free of charge, so you can go and have a look at some of the actual code implementation of how Data Agnostic Services work in the context of building a pragmatic SOA framework. So that's all there, and we'll be using that as examples of best practice and code examples throughout the rest of the courses. So let's have a quick look at what Data Agnostic Services are and what's the difference. So essentially, Data Agnostic Services builds on everything we're going to talk about for SOA frameworks. So everything you're going to learn about building a service, all of the interface, implementation, deployment, everything that's related to service-oriented architecture and building services is fundamental to the idea of Data Agnostic Services. The big difference that we're implementing with Data Agnostic Services, or DAS, is that instead of encapsulating the customer data in the customer service and the order data in the order service, we're abstracting the data into a data agnostic data at rest service. So all of the information about customers is not in the customer service, it's in the data at rest service. All of the information about orders is not in the order service, it's in data at rest. And what we're doing is we're providing a generic data storage service for record information that's using a data agnostic format. It's as simple as that. But that simplicity addresses a ton of the fundamental concerns and limitations associated with building out services and applications at scale. So the idea of data agnostic services is to look at data in its four basic states. Data is either at rest or it's in motion. So data at rest and data in motion we'll talk about in data architecture tutorials. And then data is either being presented to a user and the user is interacted with the data, or data is in action. It's basically being changed or modified by some automated process, either called in response to a user action or as part of some scheduled or event-based trigger mechanism. And this is what we'll be focused on in this presentation. So data is in one of these four states. It's at rest, it's moving between applications, it's being presented to a user so the user can operate on it, or it's being acted upon by some sort of automation process. And the fundamental difference for data agnostic services, everything else that we've talked about for SOA, coding standards, frameworks, building interfaces, and so on, is exactly the same. The only thing is, let's abstract the data away from the customer service, away from the order service, put it into a generic data at rest service, and then everything has direct access to data at rest. So let's think about what data presentation means. Essentially, data presentation is the user experience. It's the presentation of any type of data to the user across any channel that the user may be using. So whether the channel is a web, is a mobile device, is a tablet, is a desktop, data presentation covers the whole gamut. What are we presenting? We're presenting records, we might be presenting reports, we might be presenting Powered BI dashboards. So essentially any sort of presentation of data across any channel is all under the scope of data presentation. One thing where data agnostic services really stands out over traditional custom application design is that we take the idea that most records are presented to users on forms. And a form is simply a set of tabs, rows, and fields. Okay, so whenever you've used an application to basically fill in a form, push a button to initiate workflow, you've been presented with a page or a form. The form has had tabs, it has rows, and on the rows there are fields that you've actually entered data into, read data from, or buttons or controls that you've pushed to actually initiate something. Now there's two choices. Okay, one is we can use dynamic page builders, or we can create custom forms. So most applications at the moment will build custom forms. So if I have an application that needs to display 100 different types of data, so a customer that's a corporate, a customer that's a non-profit, a customer that's a person, an order for product type A, an order for product type B, an invoice, I might have different forms for every one of those different concepts or different types of object that are going to exist in the data set. So I might have applications with hundreds or possibly even thousands of different forms, and each of those forms is still going to have tabs, rows, and fields. Okay? So I can either custom build all of that form code, or I can use a concept called dynamic page generation. So essentially the idea of dynamic page generation is that we're going to take a data agnostic record format such as XML out of our data at rest record storage. We're going to combine that with a form definition. So this is the idea of using data, not code, to use a generic service to display a result. And the combination of the data agnostic record with a form definition that tells us how to present that information to a user gives us the ability to render the user experience in real time. And this enables us to take into consideration the roles assigned to the user, the data that's available in the record, the current state of the record, and all of the business logic around that record, and encapsulate that as a data definition of what a form should look like. So instead of us having to hard code all of that custom code, we actually do that in data, not code. So when you consider that most of the code in an application is what we describe as user experience CRUD, create, read, update, delete of information, what we're really saying is, look, if I'm putting a form on display, I need to be able to determine what the user can see, which fields in this record does the user see, which fields on this record can the user update, which buttons on this form can the user press. And as we've already said, this depends on the roles assigned to the user, the state of the record, and potentially a bunch of business rules. Okay? And typically, that's all custom coded. But if we eliminate that custom code, then we've eliminated 90% plus of the code and testing in the application. So this gets us right back to write less code, do more with data. So one of the cool things of data agnostic services is because we've gone from saying, here is a customer, here is the customer data in the service, and here is the order, and here is the order data in the service, we're saying that that customer data and that order data has been encapsulated in a generic record format, XML, inside a data at rest service. Whether I'm displaying a customer or displaying an order, I'm going to the data at rest and saying, give me this record, and then give me the form definition that's associated with this record, and then use those two sources of information and a generic service to display the real-time presentation of that user experience to the user. So in data presentation, the simple abstraction of data into a data at rest and the use of a data agnostic record format such as XML, or you could implement with JSON if you would rather go down that path, basically gives you this ability to eliminate immediately 90% of the code that you would otherwise have to build and test within your application. So what about the other 10%? So essentially, if you think about a form that's processing an order, you might have a button on that form that's going to do some workflow. And ideally, that workflow is going to go and it's going to do whatever it's doing. And essentially what it's doing is updating data. So if we look at the basic definition of SOA services, we already know that the implementation of those services are supposed to be stateless, encapsulated, and abstract. Okay, but why not take it one more step? Why not make those workflow services dataless as well? Right, so if you remember back to the original diagram on data agnostic services, the data is in the data at rest service. So what we can then say is, well, if I've got a piece of workflow that I need to do, what I need to do in that workflow is talk to the data at rest service to actually get the data that I need to process the service. I will do the required workflow processing for that service, and then I will write the results directly back to data at rest. Job done. So what this enables us to do is flatten out the service hierarchy. Essentially, I don't need, if I'm placing an order, to call the customer service to say place order, and that customer service then calls the order service to actually place the order. And the order service might be calling an order line service or some sort of fulfillment service and so on. So you may have some sort of nested hierarchy of services, essentially because every workflow action, every data in action service has immediate access to data at rest. I can eliminate the need for an extensive service hierarchy. I can access the data I need immediately within that service to operate that particular function and write the data directly back to the data at rest service as soon as I've finished it. So this enables us to hit all of the desirable characteristics of a SOA service in general. It enables us to flatten the hierarchy of a service-oriented implementation, and it also means that you can then build and deploy much smaller and simpler services. So for example, if I'm processing an order of product type A, and to do that I need to do workflow A, and then somebody comes along and says, well, now I need to do an order with a product type of B, right? I don't need to rewrite my whole order service to now deal with A or B. I can just say, well, okay, you know what, I can now write and build a workflow for product type B, and build and deploy that function completely independent of dealing with order type of A. And that gives me a much smaller, simpler service. Right? It's easier to extend, it's easier to version, it's easier to operate, and it's easier to maintain. So one of the really cool things, again, about going to data agnostic services is because we pulled the data out of the service and we've put the data into the data at rest component, it means that we can build these much simpler, much smaller services to actually operate on that data. And another really cool thing about this is that we've got all of the data inside the data at rest model. So we can now apply a consistent security model across all of our workflow and all of our user experience. So I can basically put a security boundary around the data at rest. I can validate the user has access to the record, prior to them pushing the button that says I want to do this workflow. And then when my workflow, my data in action service is executed, I can validate that data in action service using that user information has access to both the individual record and also has access to the action they want to execute. So this gives us a really cool way of enforcing security right the way through the application architecture framework, from the user interacting with a record on a form on a user screen, right the way through to the user trying to process an order or an invoice or whatever they're trying to do. And at the point where that invoice is being processed, to make sure that the security model is being applied and that command is still valid for that user on that record, irrespective of whether that request was made through the user experience or through some scheduled job that's maybe come through a message channel or something else as an initiation mechanism through the data in motion. So this gives us much more flexibility in the development and operation of the services. It also gives us far more efficient services, and it eliminates most of the limitations and requirements for anti-patterns that normally are implemented in SOA implementations. So as you can see, application architecture, we've got a lot to talk about. We've got a lot of tutorials to do. Each of these slides that we talked about in this deck is going to be generating a number of different tutorials that will look at application design. As we go through this process, we will use some examples from service-oriented architecture. We'll be looking at different SOA patterns, and we'll be looking at how Data Agnostic Services addresses many of those limitations, and we'll be giving you some coding examples in terms of how to actually build and implement service-oriented architecture in general, and also how to build for Data Agnostic Services in particular.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.